Now we're going to take a look at some vertical flips, not horizontal flips. First of all, we're going to look at f of x equals negative square root of x. So here we have the square root of x. What happens if we put the negative symbol outside of the square root function like this? We can see that what happens, the graph flipped over the x-axis this time. Now it flips over the y when we have the negative inside the square root, but it flips over the x when it's on the outside. We took the square root function and flipped it vertically over the x-axis to get our new transformed function down here, the negative square root of x. Let's do that for p of x equals x cubed. That's our parent function. I'm going to put a negative in front of our f of x. And now we can see p of x was actually flipped vertically over the x-axis. Now it does turn out to be exactly the same. Just going to do a little bit of review here as if we do a horizontal flip, and that's called an odd function. Okay, but anyway, you do get the same graph, but it's still considered a vertical flip. Let's do one more. We'll just do absolute value of x. You can see that when a becomes negative 1, it flips horizontally. So the question is, why is this happening? We can see that when a is equal to negative 1, the parent graph flips vertically. But why? So this is real easy to explain. You're just taking your original function value and you're putting a negative in front of it. So all the y values are going to change signs. Whatever y values are negative become positive, and whichever ones are positive become negative. So for example, p of 1 is equal to 1. Well, if we put a negative in front of the square root of x, it makes the new value, y value, negative 1. And here's that example. Here's p of 1 is equal to 1. If we put a negative in front of it, the new y value is negative 1. It keeps the same x value, okay? The y value becomes the opposite. Now, in order to see how the negatives flip, let's look at x cubed. Okay, for example, the original, here's the parent graph right here. Let's say p of negative 2 is negative 8. Well, if I make the y value negative, it's going to flip the negative 8 and become positive 8, still at negative 2. So there's an example of making a negative positive. Another point on our square root function would be square root of 4 is 2. Again, this is very simple to understand. I'm going to be taking that same y value of square root of 4 and making it negative, so my new y value is going to be negative 2. Okay, so here's p of 4, 2. But for our f of 4, our transform function is going to give us negative 2. In general, all you're doing when a is equal to negative 1 is putting a negative in front of your whatever your function is. Whatever your function is just p of x, so therefore f of x is just negative p of x. It's really that simple. It's a lot easier to understand than horizontal flips or horizontal transformations. You're making the function value negative. Here's a very simple proof. Suppose f of x equals negative p of x. It follows from flipping the equation that negative p of x equals f of x. And therefore you can just take p of x and multiply by negative 1 to get your f of x value, your function, your fy value. In other words, the y values of f of x are found by multiplying the p values, y values of p of x by negative 1. It's very simple. This takes much. I like the fact that the vertical transformations are much easier to explain. So here's our chart for p of x equals square root of x, 0, 1, 4, 9 for our x values. We've seen this before. Our y values are just the square root of those. We can see that if we make the square root of x, if we put a negative out front, then all we have to do is take our y values from our parent function and multiply by negative 1. It's much more straightforward because you see a negative there, therefore you make the y values negative. So with vertical flips, you're changing the y values, not the x values, and that makes sense, right? Because the y values are flipping signs. So our new y values will be 0, negative 1, negative 2, and negative 3. Again, for any vertical transformation, the y values are going to be the ones that flip, and you can see that right here for the square root function. You've got the same x values, but the y values are flipped and become negative, or the opposite sign if it's a cubic function that has negative y values as well. So here is our final transformed function f of x equals negative square root of x. The x values stay the same, the y values change sign, and that's if you have a negative that you put in front of the parent function. Let's take a look at some other vertical flips. Let's flip x squared, tangent, and 1 over x. Okay, so let's go to x squared. When we flip it, it's a u that becomes upside down. That's very straightforward. When we go to tangent and when we flip it, all of the negative values become positive of the same thing, and all the positive become negative of the same number, and the x values stay the same. And then 1 over x, we've already done this. If you flip 1 over x horizontally, it's the same as if you flip it vertically. You end up with the same thing, and that's because it's an odd function. But again, same x values for the top and bottom here. The only difference is one is the positive version of the negative of the other, and vice versa. So in general, here's our p of x function. Again, the p of x values are going to become negative. The x values are going to stay the same, as you see in this chart. Just take all the y values of your parent function, multiplying by -1, or just put a negative out front. I mean, it really doesn't matter. I'm multiplying because you're going to see that when a changes, you're going to be multiplying by a, so I want to keep it consistent. That will give you your new y values. It's just the negative version of your parent y values will give you your transformed f of x values. Therefore, here is your transformed function chart completed. Same x values, flipped y values. Alright, finally, when f of x is equal to a times p of x, again we'll look at some other values for a, and a is equal to -1, then the parent graph p of x will vertically flip around the x-axis to reach the transform graph f of x while keeping the same x values. Again, that's vertical flipping. If you have any other questions about this, let me know.